Hey, today we are learning about essential and removable discontinuities. What the heck is that? Well, we have done these before because these are just the vertical asymptotes. An essential discontinuity is a vertical asymptote, which just means it's not removable. You can't get through it. It's a asymptote, it's a fence. You can't get over it, can't get under it, can't get through it. It's an asymptote. It's essential discontinuity in the graph. The graph is not continuous because there's a hole in the graph that you can't get across. There's a line there. But a removable discontinuity is a hole in the graph. So you might have a graph that looks like this, and then there's a spot, and then, there could be an asymptote here, and we've got our little graph going like this. Well, there's a hole right there. You say, what? How can that be? Let me show you. This is what we're looking for today, removable discontinuities. Now, all the ones on the homework, some of them don't have removable. They're all asymptotes. You just have to find all the asymptotes. But if they're removable, you need to find all the discontinuities, the essential and the hole in the graph, and then you need to be able to plug that hole. And we're going to figure out how to do that too. So here we go. First example. See if we can fit it in here. How about this one? Let's see. X squared minus 1 divided by, I lost it already, x squared minus x minus 2. Woohoo! So, what's the first step? Well, the first step, we need to factor. So we are going to factor. That's right over here. Step number 1. Factor. So if I factor the top, I get x plus 1, x minus 1. And if I factor the bottom, I get x plus 1, x minus 2. You say, wait a minute, I don't know how to factor it. Use your quadratic formula. Right? And you'll find the two x-intercepts, and then factors are the opposite of the x-intercepts. You got it made. Now then, this is the same thing as this. This equation is equal to that equation, right? And what I notice is that there are numbers that are factors that are exactly the same. That means, once I factor, if I find two factors that are the same, then I found a hole in the graph. Because remember, a discontinuity is when you divide by 0. So what makes this divide by 0? Positive 2. X equals 2. And what makes this one divide by 0? X equals negative 1. Right? Negative 1 would make this one divide by 0. Positive 2. But negative 1 makes the top equal 0 as well, right? Well, if these guys are both equaling 0, they're gone, right? So the graph is actually this graph with this hole in it. And you say, what? Yes, sir, Bob. So let me see if I can show you that. I will grab it. So we need to clean out all the stuff that's there, and we need to type in parentheses. Now you have to put parentheses on the top and the bottom. So now we're dividing by parentheses again, x squared minus x minus 2. Now then, when we type this in, I'm betting that there's going to be an asymptote at positive 2 and a hole in the graph at negative 1. So let's see. Now, I can see it, so let me see if I can make it so you can see it. Do you see that there is a hole right there. Where's my little pointer? Right there. There's a graph. There's a hole in the graph. You see the graph is smooth, and then right there, there's no answer at -1. Right? Now, if you're looking at the whole rest of the picture, where's the rest of the picture? I zoomed in too much. Let's look at the whole picture. There we go. So you can tell that there's an asymptote right here. 2 is the asymptote, the vertical asymptote, but -1 is the hole in the graph. Now, let me show you on the table as well. If I look at the table, let's go from -3 is 1. Let me show you. See, there's an error at -1. Why is there an error? Because you can't divide by 0, right? That's why there's an error. You can't divide by 0. And there's an arrow at +2 because you can't divide by 0. Right? There's 2 mistakes. And now then, the hole in the graph, I can plug that hole if I plug the number -1 into this part of the graph. So let's do that. If I put -1 in here, I'd have -1 minus 1 on top and -1 minus 2 on the bottom, which turns out to be +2/3. So what point plugs the hole? That's the point that plugs the hole. Yay! So we found a hole in the graph, we plugged the hole, and I want to show you that that plugs the hole. So check this out. I'm going to zoom in again, maybe you can see better. I'm going to go to my window, which is second. So I'm hitting the second button, and then table set. Now I'm going to start at -1, and I'm going to count by 1, like this, 001. 001. Now then, notice that there's no answer at 1, right? But you can see, whoops, what did I do? Oh, go back up here. There we go. 0.01. That's what I'm looking for. 0.01. So I'm looking right here, and then I'm going to my graph, and I'm starting at. Let's start all over. -1. Okay. So if we look here, I'm at 669, 668, 666, 664, right? The one that's missing is 2/3, which you know is 667, right? That's what 2/3 is. So, what the heck is going on? We found the hole in the graph. Now, let's look at the whole graph. Let's zoom for, and let's look. Let's make it a little bit taller. Okay, so you can see that there's an asymptote right there, right? -2 is an asymptote. So if I asked you what are the vertical asymptote, that's the vertical asymptote. It has a horizontal asymptote as well. Remember, when the numbers are, the exponents are the same, it's the ratio of the coefficients, which would be 1. So the horizontal asymptote, the vertical asymptote is this, the horizontal asymptote is this. The hole in the graph happens here. Vertical asymptote, horizontal asymptote, hole in the graph happens there. I can plug the hole with this value, right? That's what you're doing today on today's homework. So let's do it again. Do it again. Okay, here we go. Number 2. How about if I just had plain old x minus 1 on top and x squared plus 4x minus 5 on the bottom. First step is still factor. Now I can't factor the top, it stays like it is. but I can factor the bottom. What is the bottom made up of? It's made up of x plus 5 and x minus 1. Hey, hey, hey! So these guys are the same, right? This one's different. So what makes the bottom equal 0? X equals negative 5 and x equals positive 1. All right? So positive 1 is the hole in the graph. How do I know? Because it's on the top and the bottom. Right? These guys are the same. That means that this is the graph that's going to show up whenever we graph it. Right? Now then, if I put 1 in here, if I put 1 in, 1 divided by 1 plus 5, that would be 1 comma 1/6. I know the number that plugs the hole because I plug 1 in. 1's the number that makes it equal 0, but 1 is the hole in the graph. It's removable because it's on the top and the bottom. I put 1 in here. 1 over 6 would be the number that plugs the hole. What's the horizontal asymptote? Well, when the denominator exponent is bigger than that, that means y equals 0. So let's graph it and see if there is, in fact, a hole at 5. So, we need to, whoops, let's type the whole thing in there. Parentheses, x minus 1, close my parentheses, divided by x squared plus 4x minus 5. There we go. Look at my pictura. Whoops. I need a wider picture, so let's zoom 6. What do you say? There we go. So I can see that the asymptote is at negative 5, right? X equals negative 5. The horizontal asymptote's y equals 0. The hole in the graph happens at 1. You say, I can't see that. Well, let's just look at the table. Right? Let's start. So we're looking at positive 1. That's what we want. And see what's happening there. Alrighty. So look. I'm getting closer and closer and closer and closer to some number. Right? You say, what number is that? Well, here I've got 1669. And on the other side, I have 1663. What's halfway between 1669 and 1663? Well, it would be 1666, like that. What is 1/6? 1 divided by 6. Bing, 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 bing. Well, I didn't use all my decimals. 1 divided by 6. 6, 6, 6, 6, 6, 6, 6. That's 1/6. Yay! We did it. See, that's what's missing right here. This one is too small. This one's too big. The one that fits right in the middle is just right, and it's 1/6. Let's try it again. One more time, and then we'll be done. So notice you have to find all the asymptotes and find the hole in the graph and plug that hole. That's what we want. There we go. One more time. Here we go. What if we had x squared minus 2x minus 8 on top and x minus 4 on the bottom? So I factor. The top is x plus 2, x minus 4, and the bottom is just x minus 4. So this one, whenever I divide by this, I find 4 is the number that makes it equal 0, but it's removable because it's in the top and the bottom, right? So that means that there is no vertical asymptote. None. None at all. None. right? Because this one is the hole in the graph. Really, you say? Yep, that's true. Now let's clear all that junk out. Clean this out, and let's type it in there and show you that this one doesn't have any asymptotes at all. In fact, it doesn't have a horizontal asymptote. It doesn't have an oblique asymptote. It doesn't. So, where am I? I'm doing x squared minus 2x minus 8, close my parentheses, divided by x minus 4. Bing, bing, bing. So, let's see. I believe. Now, can we see the hole in the graph? I don't think so. We might have to zoom in just a tiny bit. So I'm going to zoom in, see if that does it. And then I'm going to have to make it a little bit taller. So I'm going to make it taller up to 8, I think. Let's see. 8. And right there is the hole. You probably can't see it right there, but right there is the hole. And you can say, well, it's supposed to be at 4, so let's put 4 into our calculator. And so what I'm doing whenever I do this is I just go second table set. I start at 4 and I count by 0.01. You can count by 001 if you want. It doesn't hurt anybody. Right? What you're looking for is what number is the answer when 4 goes in. What number is the answer? Well, on this side I have 5.99999. On this side I have 6.0001. What do you think the answer is? It's the number in between, which is 6. Right? Now, how could I find that? I put 4 in here. 4 plus 2 is 6. Yay! So, the point that plugs the hole is this. It's removable because I can plug the hole. If it was a vertical asymptote, there's no way to plug a hole that's that big, right? There, you can't plug that hole, right? But if there's a hole in the graph over here, you can figure out what number fills that up, and then it'll be a nice continuous graph, right? Right now it's not continuous, it's got a hole in it. So if I plug it in, then it's continuous again. Hooray! Hooray! That's it. You should be able to do today's homework no problemo. Bye.